Hello, my name is Marius Acsinte, and this is the video for the final project for CSE 535 fall 2017 semester. The project that we chose is the BrainNet, also known as the Thought ID project. It's the first project in the project descriptions gave to us, and our group number is group number 13. The group members who participated and developed the project included myself, Marius Acsinte, Seidel, Prabhat Rachela, and Tarek Salama. The project objective was to improve on the current existing solutions developed in order to avoid data infringements and to improve security overall for mobile devices upon logging in. Therefore, the application purpose was to basically log in using a neural network brain signal instead of a password in a combination with a specific username. Upon entering a username, the application will play a specific video and the brain signals recorded will be sent to a server. Ideally, we would want the actual brain sensors on a subject to be tested in a lab using actual sensors. However, for this particular project, we do not have access to such sensors. Therefore, we're using the brain data, which is stored on an SD card. This data is then sent to a server that has a database storing brain data signatures for all system users. These signatures are compared to the uploaded brain signal data using an algorithm developed in MATLAB, which employs the machine learning algorithm techniques. The result of this algorithm will indicate whether the signals come from the same user, in which case the login will be successful, or and return a 0 or a success, or return a 1, I apologize, or a success, or if the algorithm is not successful, and if the brain signatures are from a different person, in which case the algorithm will return a 0, like I mentioned before, or a failure. In order to achieve all of this, the Android app shown here in the screen directly communicates using a post request with two different servers. On one hand, the remote server that is hosted in a location outside of the network, which is the network that the mobile phone that we're looking at right now is in. And on the other hand, the fog server, which is connected to the same mobile network that the phone that we're looking at right now is on. So one is outside and one is inside of the network. Both of these servers are Python mobile-based servers, which we're creating using various Python libraries such as Flask. In order to execute the MATLAB code that will generate the specific results as mentioned before, MATLAB as well as the MATLAB engine for Python were installed and set up on both platforms. Furthermore, Python had access to any MATLAB framework and could be used directly to execute functions from a remote file, such as the files containing the machine learning algorithm code. As far as for the database in which all the brain data signatures were stored, upon having a conversation with both the professor and the teacher's assistant, we decided to convert the brain data files into JSON files and queried those specific files using Python scripts in order to retrieve a subset of 900 values from each data set pertaining to each file. The reason why we did choose a subset instead of the whole overall data set in a file was purely based on the execution time, and it made it for our code to be better organized and more efficient when making both fog and remote calls to the servers. We also actually saw that using a subset versus using the whole set of data did not change the accuracy of the algorithm, so that was easier for us to determine as well. To make a decision as well. The overall flow of the application was mainly comprised of the following functionalities, and I'm going to demonstrate these in the following minutes. So as you can see here in the screen, upon opening the app, the user gets prompted with the login screen and has to either has the option to either choose if they want to use the fog or the remote server, and I'm clicking on them right now using these radio buttons, or if they want to use the adaptive algorithm implemented by our team, which determines the performance of both scenarios and chooses the fastest approach between the fog or the cloud. The cloud server is basically the remote server that we're talking about. So when you hear cloud, it's basically referring to the remote server. The algorithm that I was talking about before and I mentioned before is based on the round trip time for both the fog and the remote server, as well as for the time that it takes to convert the brain data files into a JSON file, and the minimum bandwidth between both approaches, pretty much both platforms. So as you can see here, when the app is initially loaded on a device, there are certain parameters which get set for the bandwidths and the round trip time that will then populate with the actual accurate values on the second run after the post requests are being made to each server. So in this scenario, we're using the second iteration, and you can see that the fog round trip time and the cloud round trip time are being shown. So the fog is 551 and the cloud is, or the remote is 497. So when a username is entered, as I am gonna enter one right now, that username has to match the username that's on the SD card. If that username is not on the SD card and the watch video button is pressed, an error message will be shown. So as you can see here, user not found on the SD card. There's a set of users that we put on the SD card. The whole purpose of this button to watch the video is to pretty much simulate how a scenario in which brain data is being analyzed using sensors would go while user is watching a video. So pretty much when the watch video button is pressed, then the video will show, the YouTube video link will show as soon as the brain data computation algorithm is being completed from either the fog or the cloud server. So basically right now, looking at the two round trip times in the application, as I said before, it's 551 versus 497. The algorithm that we implemented chooses the lower round trip time based on the measurements that I mentioned before, but it chooses that only 80% of the time. 20% of the time it actually goes back, and using the same algorithm, it wants to determine if the other platform having the higher round trip time has improved in performance or not. Just so we can avoid running, the same server all over time, over and over again. So right now we're gonna test the lower round trip time, which is the fog round trip time. So I'm gonna click the same user, use the same user one. Upon hitting watch video, we can see that it's using it said that it's using the fog server and that the login failed. So right now, if we look at the round trip times, those changed. So the fog round trip time is higher than the cloud round trip time. So to be able to prove that the adaptive algorithm is working, and to also prove that the cloud server or the remote server call is working, I'm going to use the adaptive algorithm, which will automatically choose the low round trip time, in this case the remote server. So let's do that, and it says, you can see using remote, and the login failed again. So I'm going to actually prove a successful login. So in this case, again, the fog versus the cloud, the fog is higher. So if we use the adaptive algorithm again, it'll choose the cloud, but I'm just going to use the cloud itself just to show you guys the third possibility of the usability of the application. So upon hitting watch video, you can see login successful for the third user. So you can see that the accuracy of the application is increasing. We did have 4 users that we used, and we did have 5 users actually that we used, and 2 of them were successful upon logging in, while 3 of them were not. Overall, I demonstrated the use of both servers as well as the use of the adaptive algorithm created by us by pretty much showing every use case scenario. The accuracy of the project, like I said, upon verifying all the user data for all the users, was 40%, which was caused by the design of the algorithm. This algorithm was designed for a different type of brain data, so for it to work properly, we would need to rewrite the MATLAB code given to us by the professor and train and optimize for a specific purpose using brain sensors. This was something discussed with the professor, and he recognized that the machine learning techniques would not be very exact given the circumstances. All the work was done, and I showed you right here represented about 84% of the total workload attributed to this project. And all that's left is recording the power consumption of the smartphone being tested for both cases when using the fog and/or the remote server, and compare the fog server only versus the remote server only versus the adaptive algorithm with respect to power consumption and performance. Another use case that I unfortunately cannot show right now, but this can be tested upon running the project, is the fact that in case the device that's being tested has a battery level of 20% or lower, which is the threshold that we define, only the adaptive algorithm option will be available to the users, while the fog and the cloud server capabilities will be disabled. Thank you so much for watching the video, and more details and explanations will be included on the final report.